Hi class, this is Bill with the continuation of our Intro to Chapter 7 on lists. We've gotten a long way through this and we spent some time talking about, in this slide, the selection sort. And what we're going to do now is take this concept and then build it together into code. I hope that if you are catching the programming bug and you're really finding yourself into this, you want to do something like this. You don't want to just take an algorithm that somebody hands you and try to implement it. You want to actually create the thing because you'll learn it so much better. You'll really understand it and your brain will get great programming exercise if you do that. So I'm hoping this is something that's useful to you, and walking through it together maybe will teach you some tricks. And I think there's some fun stuff along the way that we'll do. So the first thing is, when something is hard, when something is challenging, we always want to do some sort of design consideration here. So we'd want to draw a flowchart, or we want to make pseudocode. Well, pseudocode's a lot easier than drawing a flowchart, so let's see if we can figure that out. Let's write some pseudocode together. Remember, pseudocode is not programming, so we don't have to make it look any certain way. But let's see if we can take the ideas that we have here on the slide, and see if we can put them into some sort of pseudocode. Well, first thing, we sort of know we have to do two loops here. Two general things have to be done. But the main thing is we have to go through several passes. So we're going to have, I'm just going to label this pass, and I'm going to say loop through the item indexes. And then one of the things we have to do here is figure out what that range is supposed to be, because it's so easy to get it wrong and be off at the beginning or off at the end, or try to walk off the end of the list or something like that. And we want to get it right so that we're not frustrated when we get to code. So think carefully. How many passes do we have to do? Well, in our example that you see on the slide there, we had 5 items. We know we needed to do 4 passes. So we know that the total, the number of things that are being looped through here, needs to be 4. Well, that's great, but what do those indexes need to be? Do we want the range of that to be starting at 0 or starting at 1? Well, if you look down below, I think you'll see that there's kind of an obvious answer. If you look at our dividing line between sorted and unsorted and our little index pointer called start, you'll see that we started at 0. Right? Because item number 0 is the first item in the list. So we are in a zero-based world in Python, Java, C, most big programming languages in the universe here. So we want to do something in the range of 0 to. Now remember, with ranges you want to specify one beyond the item that you actually want to process. So in this case, we want to start at 0 and we want to process through the third item, 0, 1, 2, and 3, right? So we need to do 4 passes, and those need to be numbered 0 through 3. So the thing that we end up with is the end of the range needs to end up at 4. Now we already know we can use the list length as a clue here, but then that's 5. We've got to take away 1 to get to 4. So the range of the pass variable that we're going to create needs to be 0, and then 1, 2, and 3. So stop and think a minute if that's the right range that we need to use. We need to go through 0, and then we need to process through 3, which is actually list length minus 2 if you want to think of it that way. So if you want to think of it that way for now, 0 to 3, and then we just know that once we get to actual coding, we'll have to make sure that whatever coding choice we make will do that, right? So the example's 0 to 3. Now for each one of the passes, 1, 2, 3, 4, what do we need to do? Well, you remember that one of the things we did is we made this assumption that the smallest index, or the smallest position, was that first item. So whatever is in that loop variable, pass, we need to set the smallest item position to the start, to the pass position. Right? So if you're starting at position 0 for the first pass, you need to assume that the smallest item is at position 0. So the smallest, what do I don't want to assume there, the smallest item position to the pass position. There we go. So that makes our assumption to say, hey, we don't really know yet, so we're going to just assume this first one is the starting value, the smallest value, and then we'll fix that as we go through. All right, so that's our first item to take care of. Now we know that then we have some checking to do, and we know that we need another loop, and we want to loop again through item indexes. and the range of the values that need to happen there. Now, this one's a really good one. Where do we want to start our checks? Well, if you look below, you already have a clue, because remember, in this first pass that's described in the picture there, the first check is actually at position 1, not position 0, because you've already assumed position 0 is your smallest item. There's no point checking it. So you're always going to start 1 past that. So what are we going to write here? Well, we need to do pass position plus 1, right? That's our first check. And then how far do we need to go? Well, in this case, we've got to do 1, 2, 3, 4. We've got to do 4 checks. So what's the last check that we need to do? Well, the last check is going to be at the length, right? It's going to be at length minus 1. List len minus 1. All right? So that's our ranges. Now again, we're not writing Python. Please understand, we're describing a general solution, and when we translate it into a language, that language's specific quirks have to be taken into consideration. So we're not writing Python here. All right? So does that make sense? Stop and really think about that, and convince yourself whether we have the right data here, because it's very important. Notice that I am foregoing the desire to jump in and start writing code, because if I can get the thought right, the logic right, then I'm going to have a much better chance of having a correct program. So we know that's great. So we're going to loop through item indexes, 1, 2, 3, 4, 1, 2, 3, 4. Now for each check, what do? Well, we need to take, if the item at the check position is less than the item at the smallest position, right? So if we find that the thing we're checking is smaller than the thing we believed was the smallest. Now notice I'm carefully using pause or position when I'm talking about the indexes into the list. We have to be really careful, or we will start doing some wrong things here. In fact, I'll show you a very easy coding mistake that you might make here. So if you find that the item at the check position is less than the item at the smallest position, what do you need to do? Well, we know that we set the new smallest item position to what? Well, we set it to the thing at the check position, right? So set the smallest item position to the check position, right? So that should make sense in terms of remembering. We didn't do any swapping at this point. Remember, in the selection sort, our pass is just looking for the smallest value as it loops through this inner loop. Hopefully that makes sense to you. Now, what happens at this point? Once we have processed the inner loop, we know that we have encountered a new smallest value. So we're going to come back out here. We know we're done with this first inner check loop, and now we can do the swap, which says swap the positions of the pass, the item at the pass position with item at the smallest position. Right? Now notice we don't swap check and smallest, we swap the pass. Why? Because the pass is the thing that's also marked as the start, right? The pass lets us know where we started, and that's the one that needs to be swapped in this. So in our concept in the diagram, we had a start pointer. Well, it turns out pass, the thing that's looping through, is our start pointer. So that's the thing. And again, be careful of working on positions versus items at the position. Again, easy coding mistakes to make. All right, so that's our that's our concept, and strangely enough, that's it. Now, since we're going to write that as a function, one of the things that I always do, in fact, as soon as I define a function, I always start with writing return something, right? Sort of leave it empty, leave it blank for now, but it's so easy to forget to return something. So what do we need to return from this whole thing? Well, you're going to see as we work through this, we don't have to return anything. So I'm actually going to get rid of that, and we'll see why in just a minute. But basically, it's because of the way lists work. So hopefully that makes sense to you. Now, here's what I like about pseudocode. Let's take all of this stuff. Let's close this window, and let's jump over to a window that will hold our work. And now I have a, badly, a small program that doesn't do anything good. So now I'm just going to come into my selection sort, and I'm going to paste in that stuff. Now notice it's trying to interpret it and finding our keywords in here, which is pretty funny. And now I'm just going to come here and format and say comment out region, Alt 3. So now all of this pseudocode is made into something that looks kind of valid-y, it's valid comments, and now I can go and start working under each one. And there we go. Now, one of the things to consider here is the list, passing in the list. So this is goes back to something that was earlier in the lecture. When you pass lists as parameters, and just like when you assign variables, if you assign one variable to another variable that contains a list, you're pointing at the same list. Well, in this case, when you pass from main an array or a list of sample nums, when you receive it on this end, even though it has a different name, of course, it is the same list. You are pointing to the same list in memory. So this is why we do not have a return statement at the bottom of this selection sort, because the list has already been modified. That's not the same with an integer or something else necessarily, but it is true with certain the more fancy data structures like lists. So there we go. So I hope you see this is a great start that we've made here at really understanding and making pseudocode out of our concept. Now the video is getting long enough that I think I'm going to stop here, and then in the next video, which hopefully will be the last one here, we're going to take the pseudocode and actually write valid Python. We're going to test it, and we're going to learn some tricks about the debugger that can really help, because when you write this thing the first time, you're going to write it incorrectly. It's just the way it is, right? And some of these bugs are going to be hard to track down because this is getting a little bit complex. So we'll learn some tricks, and we'll take pseudocode, turn it into Python, and then we will be very happy with the result and hopefully really understand the selection sort algorithm very well. So continue on, and maybe stop and try to take this yourself and do that as an exercise to turn this into code, and then we'll continue on in the video. Thanks for watching.